It's really hot now, so if you can hear a fan in the background, I'm sorry, but if I turn it off, I'm going to boil alive. Anyway, let's get on with the video. So you're out of primary school, and you're heading to high school, and you're in for algebra. You've only seen numbers up to this point, but you can do lots of things with them. And we can write things down in a way where we know that two ideas, so to speak, are equivalent, separated by an equal sign. We know 7 is equal to 4 plus 3, and we can write it like this. The entirety of what is on one side of the equal sign is the same value of the entirety of what is on the other side of the equal sign. But what if we didn't know something about the equation? Maybe we're like an engineer, and we have some equation. Once again, the rules hold firm. What's on this side is the same as the other side, even if written differently. I don't know this number here, but I know when added to 3, it makes 7. I can assign something to that unknown. Instead of just a question mark or an empty space, I could add an emoji. I could call it a name, or a letter. I'm going to assign X to it, and you don't have to. It could be A, B, anything, but normally we like to use X in maths. Maybe it's because X is already rarely used in language, but don't quote me on that. So we know this X, when added to 3, makes 7, since per the equal sign, X plus 3 is the same as 7. These two things here, these are the same. Obviously it's 4, but what if the equation looked like this? Trying to simply stare at it hard enough that your brain can take every single component, compute it in the spot then and there, is essentially pointless. So we do a funny thing called reverse BEDMAS. Normally when you solve an equation, like 3 times 5 plus 2, you do BEDMAS. Brackets, exponents, division, multiplication, addition and subtraction. Well, for this, we're going to do it in reverse. I know the two sides of my equation are equivalent, so I'm going to subtract 3 from both sides. If they're equal and they both lose 3, they're still both equal. If I'm plussing and minusing 3 on this side though, that's like doing nothing. So I can essentially get rid of them, I can cross them out. Now the equation looks a bit different, with only the X on one side, and by the equal sign logic, this is the same as 7 minus 3, which is something we can solve. This is 4, obviously. On a big equation, we do the same thing as this, just about how many steps it takes to reverse BEDMAS all of the operations being applied to X and try and get it alone on one side, and we just have the numbers on the other, which gives us an exact value. I can add more unknowns too if I want. Let's add a Y. Now it's X plus Y is 7. However, we've lost specificity. There's not enough constraining this equation anymore, and X and Y could be anything. However, I can be assured that if I knew one of them, I would know exactly what the other was. If Y was 3, for example, we would automatically know that X would be 4. If Y was 2, X would be 5. Heck, if Y was 55, X could be minus 48, since 55 and minus 48 put together still make 7. We could plot this on a graph. The bottom line represents what value X will take on, and the vertical line represents the value Y will take, because if I know one of them, I know the other. This is a linear equation, because it's an equation, obviously, and the relationship is what we call linear. If I were to change X by some amount, Y would correspondingly change only that amount too. No matter the values of X and Y, they will always only change correspondingly. This at first sounds like the only way this could go, but what if X was squared? If X was 2, 2 squared is 4, so Y would be 3. But if X was 3, 3 squared is 9, so Y would be minus 2. Y definitely changed a weird amount right there. If X was 4, 4 squared is 16, and therefore Y is negative 9. So Y went from 3 to negative 2 to negative 9, which is first changing by negative 5, but then changing by negative 7, and X has only changed by 1, and 1 again each time. So it's no longer linear, but that's a quadratic, and that will come once you get this idea of variables, unknowns, into the permanent memory storage. Look out for a follow-up video on this with worked problems that we will go through to conceptualize this algebra and linear equations gobbledygook. And I'll see you next time.